The next speaker is Vivien Mak. Come on stage, please. She's a director at BNT in Hong Kong, and she will tell us a little bit about the challenges in design for tall hospitals in Hong Kong, and of course the salutogenic outcome. Of course, she will explain a little bit about the background problem. I think you hear this already the last days. The objectives, the methods, and of course the results and the conclusions. And I suppose that the conclusions will be probably health promoting design. So come on stage, please. Thank you.
Thank you, Stefan, for the introduction, and thank you, Kenneth, for a very in-depth report of the design of the North End Town Hospital, which is one of our 32 destinations for your information. So I'll start by giving everyone a little bit of background. We're looking at the ocean here. Hong Kong is an island and a peninsula put together. We have heard a lot about density and height in these past 2 days. 1,100 square kilometers of land, housing a population of 7.24 million. Our land population density, 6,690 people per square kilometer, and the district of Mong Kok, which is in Kowloon Peninsula, has the highest density, 130,000 people per square kilometer. Hong Kong has the most skyscrapers in the world, with 8,000 buildings, more than 14 floors. That's double of New York City. Landscape and site is also very important, and 75% of Hong Kong is actually rural. The landscape is hilly with steep slopes. Some sites exhibit more challenging geography and irregular shapes than the others, just like what you see on the screen, which is one of our hospital projects. Now here are some of the private hospitals in geographically challenging sites, just to name a few. The Canossa, the Adventist, Baptist, the Sanatorium Hospital, I know Miss Annalie is somewhere here, Matilda, and actually there are more. As for public hospitals, they are also meeting some very challenging sites, just like this few. Queen Mary Hospital, Kwai Chung, Princess Margaret, Haven of Hope, etc. If we take a look at one of the examples, the Queen Mary Hospital, this is what it's like in 1937. It went through 2 major expansions, 1955 and 1983, in which one of the tallest block was built, and that's Block K. So having this background, it's not too surprising to find, actually, the 2 tallest hospital buildings in Asia in Hong Kong. The second tallest is Block K, Queen Mary Hospital. It happens to be the 4th tallest in the whole world. It's 28 stories tall, building height 137 meters. And the tallest in Asia is the Li Shui Pui block of Hong Kong Sanatorium and Hospital in Happy Valley. It's the 2nd tallest in the world, and the first being Geese Hospital in London. Now here is a list of the current existing private hospitals in Hong Kong. There are 11 of them. The reason for listing them is that while the public hospitals sometimes get larger sites, relatively flat sites, especially the new ones, many of the private hospitals strive very difficultly to build what they want. And there's a 12th one coming, the Gleneagles Hong Kong Hospital. Most of the private hospitals were established by foreign ministries or independent groups in the late 18th to early 19th century. Some started as orphanage, nursing homes, or sanatoriums, and some were actually hospitals, small ones, with about 20 beds in the beginning. Hospital buildings were either purpose-built or altered from existing buildings. St. Paul's Hospital, for example, adapted a cotton mill and began service in 1918, and the original cotton mill building is still in use today, this one. A number of them are situated in the hillside, commanding fascinating views, and bounded by a limited plot of land, which was fine at those days. This is the Tsuen Wan Adventist Hospital in the 1960s, where it began. a view of it in the 1990s. It's also surrounded by residential projects. And now we're building a new extension to cater for the expansion in the original site. This is their sister hospital, Hong Kong Adventist, also situated on a hill. As for the public hospitals in Hong Kong, those they were founded since the later half of the 19th century tend to be situated in relatively flat sites, like the Queen Elizabeth Hospital and the Prince of Wales Hospital. The newer ones, like the one Kenneth just introduced to you in depth, are usually situated in flat sites, and they have less problems dealing with topography. Now, from this point on, I'm going to introduce to you a few challenges in design of tall hospitals in Hong Kong. I'm going to take a few private hospitals as the example. The high density and patient volume would constantly challenge the hospitals of the city. And the limitation in land supply pushes both public and private hospitals to maximize the development potential of the given sites. So several hospitals are becoming tall. The two red lines on the top of this slide shows how tall the Block K of QMH and the Sanatorium Hospital Block are. And the few examples I'm putting up today, Tuen Wan Adventist Hospital, St. Paul's Hospital, they are not far away. Whereas for the Gleneagles Hospital, I will explain later, there are other limitations to make it shorter. The challenges include structures. Tall buildings in Hong Kong meet structural challenges to cater for the wind loads. As you could see, there are typhoons in Hong Kong. So the hospital planning actually needs to make peace with sizable columns and beams. Sometimes basements are necessary due to some parameters such as the height restrictions. This is a slide from the St. Paul's Hospital site. It has completed a 3-level basement. And when there's a basement, the hospital layout needs to allow space for basement walls, for temporary workspace, installations, and when there are slopes, you need to cater for the retaining walls as well. So attention has to be paid in waterproofing some of the departments, especially the radiologies and the oncology departments, which are usually sunken underground. And the best solution may be to place the major equipment away from the basement wall. There are also challenges in time management, because in Hong Kong, I think it's the same elsewhere, time is very important, and many projects run on very tight programs. So some challenges include substructure works, where the time for obtaining government submissions and approval, and also underground conditions could be a hindrance to the program. So in catering for this, sometimes we would, or actually many a time, we would tender out and contract the substructure works separately in advance of the superstructure works to gain time. Then we have to pay attention to the interface between the two contracts, especially when the basement contractor is concreting the bunkers for you, for example. We need to resolve building services coordination ahead of time to settle all the required builders' work. This is to catch time. We would like to achieve water tightness of the external walls as early as possible to start interior fitting out works. How tall a building can go, there is a limit. So development potential is limited by the control of building mass in view of visual and ventilation impacts to the city. We have also heard about this in the seminar yesterday. So some of the control of building height and mass are here. There's a building ordinance, which controls the maximum building height and plot ratio of different classes of site. There are the outline zoning plans that tells you in each district, in each use of land, how tall you may go. And there are the lease documents. Some districts would be affected by the airport height restrictions. Now we look at some examples. In the case of St. Paul's Hospital, the government actually imposed maximum building height in 2010, after the hospital plans were approved, and actually construction has started by then. As seen in this slide, the yellow triangle shows the height limit for this site. which is 100 meters actually. So no offense, but it was heard that the new tower of the sanatorium hospital had actually raised some public concern on the height of the institutional buildings. So here it is, St. Paul's Hospital with the 100 meters building height limit. For the Gleneagles Hospital, which appeared to be shorter, there is a height limit too, and it was written in the lease based on town planning department's study of the site. So for that is 15 meters above principal datum, which gives a building height of about 32 meters. The case of Chung Wan Adventist Hospital is a bit different. The site itself requires a land exchange exercise, which is regarding the documentation of a new land lease. And for this purpose, we went through public consultation. And at that point, the neighboring residential projects actually objected to the height of the new building. The project was held up basically for 1 year to resolve that. And at last, we came to an agreed building height and also a distance from the neighboring developments. So given all this maximum building height, what could we do to get the floor-to-floor heights right? As a result, the palladium floors, housing outpatient activities usually, would achieve a floor height of about 4.5 meters. Operating theaters would be given a floor height of about 5 meters. The ward floors would have to share the rest of the allowed building height. So we achieve a height of about 4.2 floor-to-floor height, an extra of about 600 mils for the top floor. Within a tall structure, the desirable workflow that is essential to the effective operation of a hospital needs the support of abundant and well-planned vertical transportation systems. The last thing that a tall hospital wants is this. So vertical transportation is very important. We must allow adequately strategically located, grouped, and segregated lifts or elevators for hospitals. The diagram here exhibits the elevators provided for the St. Paul's Hospital. We have a total of 17 lifts, including 6 for staff and beds, 8 for visitors, and 3 for services, including the transfer lift between the CSSD and OTs because they are on different floors. The Chung Wan Adventist Hospital has 25 floors and is served by 15 lifts. As for the Gleneagles Hospital, although it's a bit shorter, it's 9 floors, it's served by 17 lifts because of the particular layout that we have 2 patient towers. Some additional transport systems, such as escalators, dumbwaiters, and pneumatic tubes, are very commonly adopted. And there are some special systems, such as AGVs, that other speakers have mentioned, and also vertical box fayer system may be considered. And actually, at St. Paul's Hospital, we have installed the box fayer system, which is practically a vertical carousel system, and the stations look like this. Adequate space should also be allowed for pipe ducts. It's a vertical building, so they have vertical ducts and stacks. And this supports a hygienic indoor environment. The diagram shows the pipe ducts at St. Paul's Hospital, which is one of the typical podium floors. So an effective, efficient floor layout for a tall hospital should provide an optimized number of elevators and pipe ducts at logical location that enhance circulation and also allow convenient access for maintenance without disruption to the operation of the hospital. Now we're going to look at another challenge for our tall hospitals, trees. To ensure that the city is provided by a reasonable amount of trees and shrubs, there are statutory requirements on the minimum provisions of greenery. And when you redevelop a site, and if you take trees away, you need to compensate. So there's also tree compensation requirements. We would like to take every opportunity to green our buildings and provide desirable and healthy environments for the community and building users. So landscape design, as Mr. Khan has shown is very important. Now, this is an example of what a site might look like. This is Gleneagles Hospital site. Practically, all the existing trees on the greenfield site were removed, 507 of them. And this is what's given in the site. And at the end, 470 will be planted to compensate the loss. You may ask why the numbers is smaller. They have certain formulas to calculate this, and we have to justify why. And the reason is we have limited land. So with a compact site with height restrictions, the permitted site coverage of sites would usually be maximized to accommodate building functions. Area that is available at the street level for planting is very limited. And as a result, vertical gardens becomes a common solution. All the rooftops practically will be used up for that purpose. Same for my Tsuen Wan Adventist Hospital project. Our sky garden is the receiving locations of the new trees for tree compensation. So some challenges regarding roof gardens are how we waterproof the planters. We would like to do raised planters with double slabs where possible. We would like to avoid placing planters above water-sensitive areas such as OTs, ICUs, and storage stores. Sunken planters would look fabulous from outside, but once sunken, it would fight with the headroom required below. Don't forget we have height restrictions. Especially when we compensate trees, the soil depth required is 1.2 meters. The operators would like to be given designated access for watering and maintenance of plants. And where vertical planting is provided, we would provide automated irrigation system. And of course, the species have to be carefully picked by the landscape architect that require minimal maintenance. And as a matter of fact, some operators would be reluctant to provide any plants at all because of the possible bugs and pests. So segregation, access control, low maintenance species, and management would be some answers to these questions. At IVF centers, plants with smells will be avoided. Here, these are slides about our salutogenic outcome, some case studies. St. Paul's Hospital, existing 358 beds, founded in 1898, is going to be expanded to be 550 beds. Its challenges includes a very long project duration of 13 years, 3 phases of redevelopment and basement construction, including and covering changes in regulations, changes in decisions and design. There's a 3-level basement next to a historic chapel. There are height limitations, GFA limitations, and the hospital has to go on during these years. And here is the result. The redevelopment was carried out in 3 phases. And in the last phase, the old block, the cotton mill, will be taken down and it will be replaced with gardens. So here is the typical wall floor and the facade, which takes a classical golden rectangle to match the chapel. Tsuen Wan Adventist Hospital was founded in 1964. And existing currently, it holds 120 beds. Our new extension will be 25 floors for 470 beds. A different set of challenges: extremely tight site on a steep slope, hindrance during public consultation, as I mentioned, height limits, continuous operation of the hospital within a very tight site, and a fast-track program. So we have multiple contracts, including a temporary shed to hold the lab and some outpatient clinics during the construction stage. The well-being is realized in the building form and also sky gardens. It's the key green feature of the new building. It will provide cross-ventilation for the neighborhood and greenery as well. The hospital administration office and the canteen will be housed in this floor, actually, at the sky garden. So we hope to encourage visitors and staff to utilize daylight and engage in outdoor activities. Here are some slides of internal spaces, a chapel, admissions, all flooded with daylight. The ward floors, each floor will be provided with a daylit patient lounge. The Gleneagles Hospital is a different story. It will be 500 beds. It needs to be completed in January. It's a joint venture between Parkway and NWS with input from the University of Hong Kong. The site is obviously irregularly shaped, and in addition, there's a railway track right in the middle through the site. We have height and GFA limits as well, 470 trees to be compensated, and from day 0 to operation, 46 months. So a logical stacking would enable wayfinding, outpatients at the street level, surgical suites ICU in the heart, and the wards housed in 2 wings to maximize daylight and views. They're linked with a bridge. Gardens, multi-level, and they will support patients, visitors, and hospital staff as well. The journey has to be relaxing from the beginning. Spacious drop-off, visible main entrance hall, clear connectivity. This is the first level, looking at the main entrance atrium. Staff spaces has to be, and salutogenic too. So these are the staff canteen and doctor's lounge for social gathering. So, in a conclusion I would make, building tall is possible. The number of floors may equal to the number of concreting cycles, number of mistakes that may be repeated, but also chances to make better places. Thank you.